So we've studied the dot product. You have two vectors and you want to find the dot product and you get a scalar. You just get a number out. Now we're going to study the cross product, where if you find the cross product of two vectors, you get another vector. So let's see how this is going to work. Let's suppose we've got u and v, two lovely vectors, and we want to find their cross product. Well, the initial setup looks like this. Now you might say, hey, I've seen this before. This looks like we're finding the determinant of a 3x3 matrix. You may have seen that in college algebra. And you're going to be using the same process in finding the cross product as you did in finding the determinant. But maybe you don't remember anything about finding determinants. Well, that's okay, because the operations are very simple and I don't think you'll have any trouble with this. Now, first of all, notice this first row here is the unit vectors I, j, and k. I is the 1, 0, 0, j is the 0, 1, 0, and k is the 0, 0, 1. And then because it's u comes first, u cross v, the u vector comes first here. 2, 4, 5, and then v, 3, 6, 7, 3, 6, 7. If this had been v cross u, then the v would come first. Order is important on this. Now let's look and see how we would work through this. First of all, we're going to go across the first row and we're going to select a pivot. So I'll call it a pivot. We've got this point right here, or this component right here, the I vector. And what I'm going to do is I'm going to eliminate everything below it and everything on the same row and everything on the same column. And what we're left with is this little matrix here, 4, 5, 6, 7. And then what I'm going to do then is take the I and put it in front of the determinant of this little bit, 4, 5, 6, 7. See? 4, 5, 6, 7. And we're going to find the determinant of this. Okay? Then I'm working my way across the top. I do the same thing for the j. I have the j. I eliminate everything on the same row, the same column, and then I've got this little bit, 2, 5, 3, 7. And I put that here. See the j, 2, 5, 3, 7. Now you notice a negative there. Yeah, it's going to be that way every time. I'm going to start with the I, positive, then the negative j, and then the positive k. But that's going to be the way it goes every time. Then we go to the k. Eliminate everything on the same row and column. And then we've got this part. Okay? And I put that down here. Okay, now we are on our way to getting the cross product. Let's evaluate each one of these term by term. Okay, the first one. Now, I'm going to find, I've got I times the determinant of this thing, this 2 by 2. When we're finding the determinant, we take the main diagonal here. See the product of the elements on this main diagonal. 4 times 7, 28, minus, it's always a minus, 6 times 5. See? 30. Okay? Then we've got minus j times 2 times 7, minus 3 times 5. Okay? Plus k times 2 times 6, 12, minus 3 times 4, 12. Okay, now I'm going to simplify this, but this right here is the cross product. But we don't want to leave it in this form. We go ahead and do the arithmetic here, and we've got this vector. Now this vector right here is a linear combination. I'm going to put it in component form this way. So you notice you've got negative 2, this negative and negative make a positive 1, and then 0 here. So this right here is the cross product, and it's a vector. This is the cross product of u and v. Now let's see one of the properties of the cross product. And we'll just do it by way of, we'll just continue to explore the example we have here just to note one of these properties. This is not a rigorous proof of it, of course. This is just an observation. What I want to do, I've got this vector here, this u, and I've got this vector here, u cross v. Let me do a dot product of u dot u cross v. Well, now notice how we do the dot product. 2 times negative 2, right there, plus 4 times 1, plus 5 times 0. There it goes. Now notice this is just going to be 0. Negative 4 and positive 4, that's 0 plus 0. Okay? Now let's look at v cross u cross v. In other words, let's cross product, or let's dot product the v and the cross product. So see, we go 3 times negative 2 plus 6 times 1 plus 7 times 0. And notice this also gives us 0. So what happens is, when we have this situation, when we find a cross product, the cross product is always going to have a dot product with the originals to be 0. So u cross this vector cross this vector, 0. This vector dot this vector, 0. This vector dot this vector, 0. So here's what happens. U cross v is orthogonal. In other words, it's perpendicular to both the u vector and the v vector, because remember, if a dot product of two vectors is 0, that means the angle between them is 90 degrees. Okay, so u cross v, the cross product, is orthogonal to both u and v. That's one of the properties of a cross product.